So let's look at the official derivation per se for your moment of inertia of a rigid object. So basic idea here is that as each particle will have its own individual radius and mass, we need to find the moment of inertia of each and then add them up. As a definition, it's the sum of the product of masses and of particle constituting the body, that is making up the body, and the square of the respective distance from the axis of rotation. That's the whole idea. So let's look at the derivation. Okay. Now, so we have, this is the axis of rotation, and say it's along the z axis, and you have your x and y axis as well. X, y, and z. And you have your body in this manner. What else? Okay, so say a random body, axis of rotation is that, and we'll consider say 2, 3 points. So 1, 2, and 3 points, and say the object is rotating this way, and this is a radius, that would be the radius, and that would be another radius. Let's consider this to be R1, R2, R3, and this is M1, M2, M3, and the velocity will be tangential over here. So somewhere over here will be your velocity of the particle. Sorry. Okay, now it's right. So I'm just drawing the obvious things. That's it, nothing else. Tangential will be over here, and this will be in this manner. Those are your velocities, say V2, V1, and V3. Okay, then this is your axis of rotation, and we have this to be a rigid body. So we are considering an object consisting of say n particles. It can be of any mass. So I'm spelling masses over there. You might not be able to see. I think I'll do this. Masses, say M1, M2, since there are n of them, Mn. Right? Then situated at a distance of R1, R2, ... Rn from axis of rotation respectively. Now let omega be its angular velocity, and let it rotate along z axis. Okay, so the basic idea is this. Therefore, moment of inertia of the body along, you can see the language I'm mentioning with respect to what axis, because this was one of the factors as well. I will be equal to m1 r1 square, right? We need to add all of them up. ... mn rn square. So basically I can represent this with I mi ri square. Okay, so it's the same thing again and again, but anyways, I just had to show this. I showed it.